Welcome, everyone. I'm happy to open this third day of our training. We are organizing with the EU for Ocean Coalition, VLIS, Eurogos, Flanders government, and all of you, and all our speakers and all our participants to discuss the challenges, opportunities, and the importance of marine data for sustainable development. We have had so far 2 very successful days, somewhere between 230 and yesterday a bit less, around 160 participants have joined from over 50 countries. Today I see the numbers are raising as well. We are reaching 100 soon. A new exciting day today. I hope you have been with us the 2 other days, and if you have, you will remember that we had a lot of discussions on what is fair, what is trust, what is care, how to implement those principles in reality, hands-on demonstrations, questions from audience. And today we are having a new interesting day where we'll be not only discussing about the marine data and its fairness and its ethics, but also how to connect data with knowledge in broader sense. How can we have a better stakeholder dialogue, which is driven by data and knowledge? How can we have involvement with art, with visualization, with communication, to generally translate information from science to society and to policy. My name is Dina Barkina. I'm leading policy and stakeholder engagement work in Eurogos, and I'm organizing this training with Ana Vitoria Teresa, who is an ocean literacy practitioner who has been working for over a decade connecting society with marine science through ocean literacy and engagement. And Juana Jimenez, who is an international liaison officer at Flanders Marine Institute and leading ECOPS Belgium, and also the release activities of the UN Ocean Decade for Sustainable Development. We also had huge involvement from Aris Pochel from LIS, who is an early career ocean professional herself and really helped attract a lot of fantastic speakers to this program. Let us start. Let me first present for you the program for today. As you can see, we have many speakers. And we will come back to this program in more detail, and I will present every speaker at a time. But first, I would like to start with Ana Vitoria Teresa with a recap of day 2, that we can all remember a little bit what happened yesterday and how we can build on that today. So, Ana Vitoria, the floor is yours for now.
Thank you so much, Dina. So, yes, on those 2 days, on those previous 2 days, we had shared with you also a Mentimeter, where you could give us your input to what is your knowledge, your previous knowledge about data, also if you have received any training on this area, but also what are your main challenges, and also from where you are getting data and how you are using data in your research or in your work. And one of the findings that we had from those 2 days is that this group of people that are with us, you also look for data in different places, in different portals. Some of them, for example, are EmodNet, Copernicus Marine, also SeaDataNet. You use also data to diverse purposes. Some of you are biologists, others are oceanographers. And we also saw that the data that we are using and also the concepts of fair, care, and trust are important to later support EU policies like Marine Strategy Framework Directive, the MSP Directive, also blue economy processes. We also saw in those 2 days case studies, also how projects in real life, right, are using data. And we saw the digital twin of the ocean, which is this virtual high resolution ocean representation. And you also sent to us some of your main challenges in your daily life and also in your daily career by using data. One of them is the limited access. So many of you face paywalls, also restricted data sets. You also face inconsistent formats, missing metadata to conclude your work, lack of guidance on the standards, also on how to use the principles, permissions, and workflows. And we saw that you also identified that it's important to have some training. So your training needs mainly are on ethical data handling, on fair care and trust, the three principles that we are addressing in this training, using open access tools, so GIS, for example, remote sensing, turning data into policy insights, but also into public knowledge. So engaging as well with our stakeholders. In the day of today, we will hear more about this topic. So will be also an important content for you to apply in your projects, and is strengthening communication and ocean literacy efforts. Yesterday, we saw from Hugo that around the world, there are some global disparities in how ocean science is developed, and also the access the countries have across the world to different technologies. This might limit developing countries, especially ability to implement ocean-related goals. So here we are talking, for example, about the Sustainable Development Goals, but mainly the SDG 14, because in some countries you have difference of research structures, also limited technologies, also different skills, but also limitations on human resources. You also have unequal access to technology, and knowledge leads to a major data and sampling gaps, especially in the global south. So this is one part, an important map that Hugo has shown us yesterday, that shows especially how some countries have more access also to ocean science and technical skills, and it shows also how data is connected to this conversation. We saw yesterday as well the importance of creating a data management plan. So this data management plan is what will also support you to have effective data management, create quality checks, a proper backup, and clear meta standards. So we saw as well that data is part of an important process of planning prior, during, and after your research. So we see that often people think about what they will do with their data at the end of the projects, but it's important to think as a 360 cycle. Yesterday, we also discussed the importance of citizen science projects in this context for gathering data, but also to reach local citizens and schools, or even other types of targets. There was a mention to the Shell Day in Belgium and France, where many people go with their buckets to the sand to also support collection of shells, but the mapping and categorization of those shells, which later support database, biological database. There are other examples of days like this one, such as the World Microbiome Day and the World Ocean Day. So they can also serve as an opportunity for disseminating the importance of data. And we saw as well from Rita Novo yesterday how data has as well an infrastructure behind. So you can see from this image here that you have different types of devices, and also from air to deep water, that are able to collect data, which later serve to the purpose of our research. But somehow those infrastructures are invisible to our eyes because we mainly gather the data from the databases. So it's also interesting to see how it's connected to this cycle. Yesterday, we also heard from Juana the importance of science on the resume that she did by the end of our session, The importance of science diplomacy and also co-design was highlighted on her talk, because those are ways to make science more responsible and inclusive, ensuring awareness at every step of the process, from collecting data to observing data to modeling and applying it later. Juan also mentioned it to us that applying the fair care and trust principles is more than just managing the data formats or storage, because it requires a change in attitude and behavior on how we process the data, how we deal with data, but also how we need to make sure that ocean knowledge reaches later policymakers, educators, communities, not just the scientists. So somehow we need to make data more available outside of this bubble. And why fair care and trust are so important. Yesterday, we also had this Mentimeter with you, and you mentioned it that the principles are important to build trust in science, share data with trust, and make sure the data helps both society and research. Because also working together, we can include people from all over the world being responsible and sharing data ethically. We can also make sure that it supports sustainable development, respects the communities that held many of this data, and benefit those who use it. So we saw as well on those days that some data are also connected with communities, and we need as well to avoid parachute science by getting this data, but later not recognizing their purpose. So we saw yesterday as well from Hugo that there are many ways to make those efforts more visible. And this is an important part of our discussion. So thank you so much. And now I pass to Dina.
Thank you very much, Ana Victoria. It's a great recap. Let's move on, dive in deeper into fair data. And I'm happy to introduce to you Charlotte de Haan from Flanders Marine Institute, who will tell us about turning data into fair data. Charlotte works on ocean health, limitation of pollution in the Flanders Marine Institute's data center, and a lot of different relevant international and European initiatives. Charlotte, the floor is yours.
Thank you very much, Dina, and also Anna for the nice introduction. And also thank you to the organizing team for this interesting training. I will share my screen.
Perfect.
Yes. Okay. So yeah, I'm Charlotte, and I work at the Flanders Marine Data Center as a data manager and data steward, supporting data management within projects, but also for individual researchers. During my talk today, I will explain to you how we implemented the FAIR principles and open science within 2 citizen science projects, mostly with a focus on standards or standardization and data sharing. So the 2 citizen science projects are Sea-Watch B, which is a regional project here in Flanders, and Plastic Pirates Co-Europe, which is a European-wide project. Both projects deal with collecting litter monitoring data at the beach, so at the coastline, but also in rivers and riverbanks in the case of Plastic Pirates. And Sea-Watch B is also collecting biological data. Those 2 different projects are different in the sense that they are working at another geographical scale, spatial scale, and they also use different methodologies, but they have quite a similar approach when it comes to the general data flow. So in this next slide, you see an example of Plastic Pirates, of how the data flow is going, which is quite similar for Sea-Watch B. So first, citizens are collecting data and sampling using standardized methodologies. And then in the next step, the data are being gathered in a central space with backup. And in a third step, data are being validated by local experts using also standardized protocols. During this step, it's also important to translate the data into English, because often in citizen science projects, data are being gathered in the local language. And then in a third step, you have the step of, the fourth step. This is a step also very important to harmonize the data. So in the case of plastic pirates, data are coming from a lot of different countries. It's important to get all those data together in the same format, also standardize those data. And during those four first steps, they are all involved in quality control as well. Then regarding standardization, you can do this on different levels. You can standardize metadata and data, but also methods, and also the data structure or format. In the case of Sea-Watch-B, we use the EmotNet beach litter format, which already uses several standards and controlled vocabularies. And we also used the joint list of litter categories, which is meant to already provide predefined categories for marine macro litter. In Plastic Pirates and as well in Sea-Watch-B, we also tried to pay attention to smaller things, but that can be very important, such as standardizing dates and time, and also coordinates, because often researchers are writing a date in many different formats, and this can cause quite a lot of confusion, because sometimes it's not even clear what the date or what the month is, for example. Then we also used vocabularies within the NERC vocabulary collection. So also predefined terms with a unique ID. For example, we did this for plastic polymers when Plastic Pirates is analyzing the micro litter. In case there is no standard available for your data, then it's very important to just be consistent within your data set and explain what is in your data set. So explain, for example, the column names you use within your CSV file, for example. Explain what the different values can mean, and talk to your peers. That's also a very good idea. And of course, it's a learning process. In case of citizen science projects, also something to remember is to try to minimize free text fields, because this can make the process of translation and harmonization and standardization much more difficult. So we'll already provide them with predefined terms they can choose from. So the last steps in the data flow are archiving the data on a longer term and disseminating the data. So in the case of Sea-Watch-B, we provided metadata for the project itself, and we linked this metadata to the metadata of the actual data set. And then we provided an identifier for the data set via a metadata catalog, our marine info catalog of lists, which is open to everyone, and we archive the data in a data repository. For Plastic Pirates, we used something else. We used Zenodo, but it works in a similar way. And we also published the sampling methodology, which could also be linked to the dataset records. Here in this next slide, you can see a part of those metadata records in the catalog. I circled in red some things that are important to pay attention to. So first, the identifier on your right, on your top right. Then also a citation is provided, contact details, also a license or an availability statement. The files are linked to the metadata, so they are findable and accessible also. And then also important, the contributors are linked to the data with their org ID, and also the institutes with their ROR ID, which is also a unique identifier for institutes, such as a DOI for datasets or an org ID for persons. Then this is just a slide to mention that there are clear and commonly used licenses available, and that not every license is an open access license. So if you want to open up your data according to the definition of open data, then it's important to check if you provide a license that says that everyone can use your data. So you can check it out via the link. And then in general, about disseminating your data, sharing your data can be different for different data types. And also the procedure to share your data can be different for different data repositories, but the basic information that you provide stays the same. Also linking everything to each other. So for example, datasets and publications is very important, and you can also publish protocols or code or scripts. A difficulty we had with citizen science projects is how to acknowledge citizens, because there are many people involved, often also children groups sometimes. You have the GDPR regulation from the EU, you have different levels of participation, sorry. So in case someone has a very good suggestion about how they approach this in their project, in their citizen science project, you can always suggest this. Then the last step was providing the data to data infrastructures, international data infrastructures, to reach a wider public. This can require some extra reformatting of the data, but is already easier if the data is fair. Also, data infrastructures are sometimes linked to each other, as I think was already mentioned by Katrina as well, and they can have different purposes or different audience sometimes. So the main key takeaways I want to give you is that it's not always easy to implement the FAIR principles, but try to do as much as possible. And it makes it easier to use the data, the citizen science data, for research, decision-making, and also education, which has a higher impact on society later on. And FAIR data is a spectrum. So it's not that data is either fair or not fair. It can also be something in between. And last but not least, your future self can be grateful if you already implement the FAIR principles at the start of the research data lifecycle. So thank you very much for listening. And if there are questions, please feel free to put them in the chat.
Thank you very much, Charlotte. Great and clear introduction, and I think you have already some questions in the chat. We will also have a dedicated Q&A session after all the speakers have have made their statements and introductions, and we will also have some Mentimeter sessions. So please use everything that you can to ask your questions to our speakers. I will introduce now the next speaker, and also ask all the future speakers, and thanks Charlotte for keeping to the time, also for the others, do the same and keep to 10 minutes per intervention, please, so we can have enough time to discuss. Our next speaker is Lancelot Blondel, who will speak about smart fisheries, how to centralize fleet information through GIS. Lancelot is working at the Belgian Flemish Research Institute for Agriculture, Fisheries and Food on digital transformation as a way to sustainability. Lancelot, the floor is yours, and thank you very much for sharing the screen already. We see the slides perfectly.
Hope you can hear me as well.
Yes.
Okay. Well, hi everyone, and thank you for the organization for having me. My name is Lancel Bondeel. I've been a researcher here at ILVO in Belgium for the past 10 years. For at least 8 years of that, I've been specialized in automatic data gathering on board of fishing vessels. And it's with great happiness that I can present you my little pet project called vistools, where we focused on automatic data gathering on 37 vessels. But this story will be from an angle on how difficult sometimes it can be to maintain fair data principles, or not the fair principles, but the openness. What are the potential pitfalls, and how we can alleviate these issues when you primarily focus on working together with sensitive data from fisheries. So to start, I'll first give you a short introduction why vistools was made. So our Belgian fishery, which is a fairly small fishery of 50 vessels, is facing a lot of challenges. Sorry. The fishermen feel threatened because a lot of offshore wind farms are being built that take away their core fishing grounds. There are no tick zones. Brexit is also unclear how many quota they will get in their waters. And climate change is also a major issue for them because the fish stocks are starting to shift and makes spatial aspects very unpredictable. They have to search for more fish, but fuel prices are going higher. So we decided to develop tools to help them guide in these more difficult times. And for that, we focused on automatic data gathering from existing equipment on fishing vessels. So most of our vessels have a GPS, a traction sensor, that's a kind of safety sensor that gives a warning if the net is stuck on something, but also gives us interesting data like rope length. Then weights for every fish that is kept, it's weighed on a weighing scale. And then there's a fuel meter that gives us information on fuel consumption of that vessel. Almost all vessels have this information, but it has never been combined and used in real time to inform science, but also provide information to scientists or fishers themselves. So we developed a little machine called a concentrator that combines all this data into a centralized timestamp, which is then sent to us via satellite. It can be used by science, but primarily to keep fishers happy. We have developed a tool that provides fishermen with insight on how lucrative their catches are, how much fuel they consume to get those catches, and give them more high-resolution insight. Because we believe that if the fishermen are happy with gathering this data, the system in the long run will be more sustainable. So this tool looks a bit like this. For every tow, you have information on what is caught in that area. On the left side where you see the mouse now, you see each different species and where the hotspots are. And you can see this information for catch period of effort. So per hour, how much did they catch, but also how much revenue they generate. So that's a tool that we primarily developed for fishers to gain more insight in their efficiency. And this is being used by 37 vessels now, but also if you combine the data, it's relevant for the sector as a whole for monitoring transparency and integration with the supply chain, for instance. Now, we would also, as scientists, like to use this data to do more sustainability research, which we also do, to provide fishers with more insight on their impact at sea. So ecological impact, here on the right, you can see a map where the green areas are. There are habitats that are not super sensitive to fishery, but the red ones are actually areas that should be avoided because there are long-living habitats or long-living communities there that have a big impact when fishery passes there. But of course, the story for sharing data with science is a lot more easier if you can tell a positive story instead of a negative one. So that's where we start to have some resistance. And the challenge is to do this in a constructive way. And for that, I also have a question for you. So that's the first Menti. I guess I'll stop sharing my screen now to share it, if that's okay.
Yeah, I'm sharing.
So here, my question to you is, what do you think is the most sensitive aspect about data sharing for fishers?
If you wish to join the Mentimeter, you can use the code which is on the chat or the one that is on the top of the page.
I already see location and catch size. Pretty good. Competition is also an interesting one. All right. Good ideas. I see for now that indeed you have the most important ones, because I don't think we have that much time to open it, is catch size, location, competition of fish. So let's start with that. I think, so thank you for the Menti. I'll go back to sharing my screen. You should be able to see my screen again.
Yes.
Yes. So it is true that a lot of this information they have is focused on their personal trade secrets, and that's very much a reason why they would not like to share this data. But their biggest fear is actually that this data would be used by control, so that enforcement could have more insight in the data that's being gathered, and that the data they share with an institute like ILVO that we store could be used against them in court, for instance, because in general, they have trust with scientists, but they don't trust control. But also, if the data would be somewhere available and open, so that offshore wind farms could use it to prove the fact that there's no fishery there, so they can build their farms there. NGOs could use it against them for arguments. And that's the main reason that data can be fair, but not very open. So we want to maintain trust with them by saying you as vessel owners are owners of the data. We can only use the data with permission. For that, we have data sharing agreements. And in the initial phase, to keep them warm for the idea of data sharing, we are focusing on research that is a win-win situation for them. So it's a benefit to us as scientists, but also to the fisheries sector. What kind of research is that? It's, for instance, focusing on improving fuel efficiency, precision fishery, but also spin-offs like traceability, gathering eDNA, and kitting fishing vessels out as a kind of passive research vessel. To give you an example of this, in the Iliad project, and this also runs on EDITA, by the way, we created a catch prediction model that tries to predict for the coming 5 days where there's high incidence of catching their target species, which is sole. So this information can lead to something we like to call spatial selectivity, so that we can steer fishers towards areas where there is high chance of catching their sole or the target species at landing side, while avoiding sensitive areas like I showed you earlier. And this is the way that we try to build trust, show them that we do not insult their trust in us by creating these win-win situations. So in short, to summarize, the data technically we gathered, the interoperability aspect, every data is gathered in a standardized way, fully automatic, every 10 seconds from each of these fishing vessels in a standardized format that is also open, called the Poseidon format. And we have pushed some of this data to eModNet. The model can also, for instance, run on ED2 and also in other digital twin, Iliad ocean information model. It's reusable. Everything is openly documented. Not only the data itself is reusable, but how we set up our methodology is fully available on the link at the bottom. And it's also validated in many different ways by us internally, but also externally. It's findable with structured metadata and will soon be also made available via a platform called Just Connect, where you can access the data and automatically ask permission to the vessel owners to share their data. But it's the accessibility that's a little bit difficult because of the trade secrets, because of the fear of control. And I hope in this way, by giving them more trust through control, through data sharing agreements, we hope that the threshold for them to start sharing this data will be lowered in the future. So that's very short, my presentation. I think I've added one more Menti that's primarily relevant for me, because I'd really like to know how you could find value in the type of projects that I've showed you. So hopefully this could also be shared. And outside of that, I'd be more than happy to answer your questions. Thank you very much.
Just to mention, for the other Mentimeter, the link is the same, so the code as well is the same.
We are receiving some questions to you, Lancelot, and I can see people start responding to Menti as well. We will address them all in the Q&A after the speakers. But you can already screen and prepare.
Yes, thank you. And thank you for your attention.
We will keep running the Menti for a few more minutes. I think it will be good, maybe, and then we will share with Lancelot the results. It is very good to see how this data can be actually used. I think we have some interesting results there already. Thank you for sharing. So the Mentimeter will stay open. You can keep adding to it. It will be very valuable for us all. And in the meantime, we will move on in the program. The next speaker is Cyrielle Deleven, who will tell us about the European project, which is called Blue Cloud 2026. It's because the project is ending in 26, but the Blue Cloud, of course, continues. Blue Cloud is an interesting cloud infrastructure for marine data, which is going to be integrated with Digital Twin Ocean we heard about on the first day. And Blue Cloud also develops interesting training opportunities on data, on fair data, and virtual labs. What those virtual labs are, Cyrielle, the floor is yours to tell us.
Thank you very much, Dina. I'll share my screen. Yeah. All right, can you see it? Great. Well, thank you very much. Thank you everyone for being here. So I'm Cyrielle, I work for Blue Cloud, but I'm affiliated to VLIS, so the Flanders Marine Institute, as many of our speakers today and the previous days I saw. It's been very interesting to hear the previous presentations as well from Charlotte and Lancelot. Blue Cloud is also a good example of what you can do with fair data and how it looks like when you work all together to create platforms that are available to everyone. So Blue Cloud, as Dina introduced, it's a project. So it started in 2023 and it's going to end in 2026. But after the end, it's going to be an EOSC node. So it's going to be part of this open science community. And we also very closely linked to Editor that was introduced by Marina on the first day of the training. So Blue Cloud in a nutshell, it's a federated European fair and open research ecosystem for everything aquatic, so ocean, seas, coastal and inland waters as well. And the goal is really to evolve this pilot ecosystem that was created in the first phase of Blue Cloud, so before 2023, into a federated European ecosystem that really delivers this fair and open data with the help of analytical services and those VLabs that I will introduce in this presentation. So I've included in the slide some additional information in case you're interested on how these European projects work. But most importantly, it's a big consortium. These kind of projects can only exist with the help of many experts from Europe, mostly in this case, but it could also be international. But we're more than 40 institutes from 14 different countries. As I said previously, we're closely linked to Editor. So Editor is the European digital twin of the ocean, if some people weren't there on the first day. So Editor is really the core infrastructure of what we call a digital ocean. So they're trying to replicate everything that's in the ocean in a digital platform so they can be available to everyone. So citizens, aquaculture managers, fishermen, researchers, obviously. But this kind of platform can only be built based on what already exists. So it's closely based on eModNet and Copernicus Marine Service and some smaller projects such as Blue Cloud 2026. So in Blue Cloud, we have what we call a virtual research environment. What does that mean? Well, it means that it's one place where you can access the data. So you can discover it and access it. You can download it on your computer, but you can also store it, share it, and preserve it on the platform itself. So I guess that answers one of the question or challenge that was introduced at the start of the session, to kind of bridge between countries. It is true that we have different capabilities, different network skills or access. Well, while using these kind of platforms, everyone has the same access to the same information. And I think that makes it very interesting to kind of bridge the differences that we have sometimes between continents or between research institutes. Here, everyone's equal, everyone has access to the same thing, and we can all analyze it in the same way if we want to. So it's really to support researchers, support scientists in doing science as it should be. We really want to enrich their activities with information that's reliable, that directly comes from the blue data infrastructures, and try to reduce the issues regarding technologies between the institutes. So on top of this virtual research environment, we've created virtual labs, so virtual laboratories. In general, the term virtual laboratories means that you can share data in that virtual laboratory. We have what we call a workspace where you can create R scripts, Jupyter notebooks, etc. You have a data space where you can store your data, and you have repositories, but you can also use the social networking, so you can chat with other people that are working in the same workspace. You have your user profile, so people can know who you are. And you can create, as I said, the notebooks, as you have access to RStudio and some other applications as well. So now I'll introduce the virtual labs that we've created as part of the Blue Cloud project. There's 5 different virtual labs on 5 different thematics. Each of the virtual labs was created by a consortium of experts from different institutes that have been working on these subjects, and that kind of came together and shared the data and models to create one big application that is available to you and to everyone. Everything is open, and you can access it through the Blue Cloud platform. So as you can see on the top of the slides, they gather the data from the blue data infrastructures. So we have access to Aerobis, Wikio, eModNet, obviously CDataNet, ICOS, and many more. These are just some examples. And then within each VLAB, they get the data from different BDIs. So when I say BDIs, it's blue data infrastructures. So the first VLAB is, the thematic is about coastal ocean observations along Europe. The VLAB 2 is about coastal currents from observations. The third one is the carbon plankton dynamics. And the fourth one is marine environmental indicators. And the last one is the global fisheries atlas. So the first one, coastal oceans observations along Europe, was built by IH in Portugal, the Instituto Hidrográfico, SOCIP in Mallorca, and IEEE, the French part of IEEE. And they've created 3 services. So once you enter the VLAB in the website, and I think some links will be shared in the chat, and I've also prepared a slide with all the links that you would need if you want to access these virtual labs. The first service is about the transboundary processes and connectivity. Then you have extreme events and ocean gliders. The research question before this virtual lab is mostly what would happen if, for example, there's pollution somewhere, how would it affect my aquaculture farm that's on the other side of the coast? So it's really to understand the processes along the coast of Europe, and see if something could migrate or travel from one place to another, and what impact it could have on, depending on your situation, on something that's there. So for that, they've used different data sets from different data infrastructures. So the Jericho, they use a lot from the Jericho community, which is a big community in coastal research. Copernicus Marine Service, obviously for the sea surface temperature data sets. and currents, CDataNet, EMODNet, and JEPCO for bathymetry. The second virtual lab is about integration of direct and indirect currents data from different sources. They've used it mostly to build a model on oil spill. So what will happen if there's an oil spill somewhere? There's actually a lot of oil spills in the Med Sea, and to better understand what impact it has on different coasts or on different ecosystems. So I'm aware of the time, so I won't cover all the data sets that they use, but all the information is available in the slides. And if you enter the VLAB of the thematic you're interested in, you also get all of this information. The third virtual lab is the carbon plankton dynamics. That one is a mechanistic model that runs on R and Jupyter, and they will try to identify the contribution of the drivers in phytoplankton dynamics and carbon dynamics. This VLAB is one of the VLABs that was built in the first phase and has been improved throughout the project. So it's quite interesting to see how first they focused on mostly plankton and now they've included the carbon dynamics in the model. And that one is mainly focused on the Belgian part of the North Sea and on the Adriatic Sea. And because everything is open, you can, if you have your own data, you can include it in the model and calculate it for your area. The fourth VLAB, so the Marine Environmental Indicators, is a web app for cloud computation of new added value data to monitor the environmental status of marine areas. It's mostly focused on the Mediterranean Sea at the moment, and they focus on marine heat waves, ocean heat content, eutrophication, and the storm severity impacts. The fifth VLAB is the Global Fisheries Atlas. It's a very interesting project because, as Lancelot said, fisheries data is always a bit tricky. In this case, we work quite closely with the FAO and IRD, FORTH, and CNR. I've been working closely with them to access the data and standardize it in a way that can be implemented in a model or in maps for this application in this VLAB. It's mainly focused on tuna fisheries and other kinds of fisheries as well. So I hope that was helpful. I know it's a very quick introduction to the VLABs because each of them is very interesting and they're all quite different, but I really invite you to go to a Blue Cloud website and discover them yourself. We've actually created an event not even a month ago, the Blue Cloud Hackathon, to really invite ECOPs and students and any type of researchers like you to go and try these VLABs, to make sure that they run, to make sure that they're used and see how they've been used as well. So this happened from the 29th of September to the 2nd of October. And we had different challenges to combine some VLABs together as well. And we invited the teams to combine two VLABs, for example, and see what kind of research question they could answer with that. So as you can guess, it was a very interesting event. We had more than 1,100 people participating, more than 100 teams from all over the world, so from India, UK, Colombia, Costa Rica, US, Canada. It was a very nice group of people that tested the Blue Cloud platform, and they came up with a lot of different projects. So the winning teams were, just to give you 3 examples of what we can do with this timer platform, is the Twin Track. So they tracked animal movement in the North Sea. They used VLAB 2 and VLAB 5, so the Global Fisheries Atlas, but also how the currents and the coastal areas work. Then we had the invasive macroalgae observing beach gas system and Kraken the Code about octopus in the North Sea. And as you can see, there's many others projects and really good ideas that people came up with. So if you're looking for research questions or what you could do with this kind of platform, please have a look. And if you're still wondering what this is, am I running out of time?
Yeah, I thought you were, yeah, a little bit.
Just a few more slides, just to give you the links for the training academy. So within Blue Cloud, we're aware that it's a lot of information, and it's a lot that you can still learn from these kind of platforms and expertise from different consortiums. So we've created a lot of webinars that are all available in our training academy platform, but also on YouTube. So here are a few examples. We also paired up with the OTGA, so the Ocean Teacher Global Academy, and we've created courses for each of the VLabs to really guide you through how to use them, and to obviously have some interactive parts as well if you want to ask any questions. So yes, and we also have fact sheets and guidelines and videos. So we really want you to understand what you can do with it. So please go and have a look. And if you have any questions now or later, please feel free to email me or to ask in the chat. And here are some links in case that's useful. Thank you very much.
Thanks very much, Serial. Very comprehensive and a lot of interesting work in Blue Cloud 26. I suggest you share some links in the chat. I'm very sure that people want to get into the labs and in your training academy right away and see what is available. So yeah, feel free to share those links, and you can increase the users of the website today. Great. Well, we will keep exploring what we can do with marine data in different thematics and different ways we can use it. We can use it to demonstrate the value to society, for example, as well, the value of research and value of the ocean. And I'm here inviting Andrew King, my colleague from the Eurogoose Ocean Literacy Working Group and Eurogoose and many different other groups as well. Andrew is also leading a region Ships of Opportunity program where scientific research infrastructures are being installed on cargo or container or cruise ships. And we will see what happens when this is being done. So very exciting research, very exciting societal engagement opportunities with the data that can be collected on commercial ships. Andrew, take it away.
Thank you, Dina, and thanks everyone for joining today. I'm happy to be here. My name's Andrew. I am a research scientist at the Norwegian Institute for Water Research, or NIVA. I'm also head of the oceanography department there, where we do a variety of different ocean-related research. But today I wanted to share with you what we call visualizing real-time ocean data for the general public. So as we heard in the previous days and also earlier today, we as ocean scientists collect data and we use them for different purposes, whether it's for research, modeling, or we heard the example of sharing it with the commercial fishermen. And so here we were interested, and we still are interested in engaging the public and sharing ocean data with the public so that they can understand what's happening in the ocean and they can engage or have something to care about related to the ocean. So my presentation today, let's see if I can get to the next screen, is about these touchscreen consoles that we developed for ocean data and ocean literacy. And these were developed as part of Horizon 2020 European project called Responsible, and also co-funding from a variety of other ocean-related projects at the European level. So these consoles, which I show here on the right side, have these touch screens. They can come in these sort of nice, approachable wooden designs or more of a metallic stand. The idea is that someone, and ideally a child or a school-age child or even an adult, can go up to it and touch and interact with the console and learn more about the ocean. So the first thing that all of these have are what we call key stories on ocean literacy, so that the public can understand some of the key issues like eutrophication, invasive species, sustainable fisheries, etc. And then as well on it, we have a feed of real-time data from what we call ferry boxes, which are these ships of opportunity observations that Dina mentioned, where sensors are installed on passenger vessels or container ships. So we show observations related to salinity, temperature, chlorophyll, and also other ocean data modules for visualizing things in the ocean. In terms of the design features, the console height and the touchscreen aspect of it, as I mentioned earlier, was designed for school-age children, and it can be expanded to touchscreen tablets or even larger tables, as shown here on the left. The target, because we have scientific equipment on ferry vessels and cruise ships, one of the target audiences were the general public, because the passengers are on the ferry or the ships that are actually making these measurements. So it's kind of a nice way to bring those two together. And the major content is, of course, available in English, but it's been translated to 6 different languages to try to be a bit more diverse in terms of outreach. The 6 ocean literacy topics, as I mentioned, can be kind of tapped on the screen, and they include stories about eutrophication, ballast water, invasive species, and these 6 different topics. An example of what it might look like, this is one for eutrophication, where there's a couple paragraphs that describe eutrophication in a digestible and layperson way of understanding and using terms that are understandable. And in this case, for eutrophication, there's a YouTube video with an explanation of how eutrophication is being tackled in the European Union. For some of the other modules, for example, the sustainable fisheries module, there's a game where you can add fishing ships, increase fishing efforts, and see what happens to the fish populations. For the real-time ferry box observations, this is an example of the data that we show from NIVA's ferry boxes. These are the ferry boxes or ships that we have running in operation in European seas. So they're running along coastal Norway, in the North Sea, in the North Atlantic. And on these ships, we have sensors that pump water in and measure different variables like temperature and salinity. So the sort of technical and very high quality data that we usually look at, we translate it into this more viewable version or more digestible version for the general public, where the ship is described, each variable is described in a way that makes sense in terms of what it means for us today and what it means for us in terms of climate change, and then a way you can view it. So I'll just quickly switch over to an interactive screen here. So this is for our Norbjörn container ship. That's the northernmost shipping line in the world. And it goes from Tromsø in Norway to Longyearbyen and Svalbard in the Arctic. So you can see here, I'll just zoom in just to give you a sense of where we are in the world. So if we zoom in here and this is how it actually works on the touchscreen. You can zoom into this area where you can see from the coast of Norway to Longyearbyen. And then if you look at temperature, for example, as you move the cursor, you can see where the ship location is. So you can see that, for example, as you get north, further into the Arctic, close to Longyearbyen, the water temperature decreases. And this is from a few weeks ago, the water temperature decreases to about 4 to 5 degrees Celsius. And then as you come back to the Norwegian coast across the North Atlantic current, the water temperatures warm up to about 11 degrees. And I can switch ships. So for example, the Color Fantasy, which has a lot of passengers going from Oslo to Kiel in this eastern North Sea, you can also see the same thing for temperature. And for example, for algae, you can see blooms of phytoplankton that are happening here close to Oslo in early October, and sort of a decline in the bloom as time goes on. Yes, then back to the slideshow. In terms of where we have these consoles installed, we have about 10 of these consoles now. They're on these vessels, as I mentioned, that have passengers, so the passengers interact with them. We also have them in science center and museums across Norway. And also, of course, in our offices, so that if someone joins us or comes to visit us, they can look at it in our lobby. And we also have these portable versions that we can bring to conferences or other events like ocean literacy events or ocean-related events for flexible demonstrations. In terms of the insights and experiences from this, we deployed these at various places. And then we also, as part of the Responsible project, tracked the usage and also interviewed users. So depending on the location, we found that we see that the touchscreen consoles get about 3,000 to 6,000 visitors per month on the passenger vessels. This red pie chart here, or slice of the pie chart, is actually from Color Fantasy, the one I showed earlier from Oslo to Kiel. So there we have a lot of passengers on a daily basis that are interacting with the touchscreen console. And actually this 3,000 to 6,000 visitors per month is quite substantial relative to other social media communication aspects or ways that we communicate with the general public. Some of the user reviews ask for more interactive content, more content for children, and better accessibility for even younger children, so younger than, say, 6 to 10 years old. We have further development planned to support sustainable development goals and ocean stewardship concepts, and also to make a web version of it so that it's not isolated only to these consoles. And I think the last note that I wanted to leave with everyone is that from a scientist's perspective, this is a really important tool. And this is a really important way and a really significant way of engaging the public, both increasing ocean literacy, so how much people understand about the oceans, and also the interest of the general public in the oceans. So I'll leave you with a list of funding that has supported this and partners that have contributed to this. Thank you.
Thank you very much, Andrew. I think it is also inspiring for scientists to see how what reaction their data and their knowledge can get from society, right? So you can see real time the data, but you can also understand how this can connect in a very direct way. Very, very exciting project, and I hope you continue and grow even further. And we will move now from this kind of visualization to another kind of visualization, something that is being developed as part of the EU for Ocean Coalition. And I will invite here Nathalie van Iseke from Seascape Belgium, who is leading an interesting project, which is called European Atlas of the Seas. It's a European Commission's atlas to see lots of different types of information about European seas, based on EMODNet and as part of the Coalition on Ocean Literacy. Nathalie, the floor is yours.
Thank you very much, Dina. Just checking maybe that you see my screen.
Yes, perfect.
Yes, wonderful. Well, first of all, thank you for all of the presentation up to now. I think they were really, really interesting and really glad to learn also about these consoles that I think are a great tool for ocean literacy. So the European Atlas of the Seas is also a multilingual ocean literacy tool. And the idea was really to make data available to everyone, citizens, school children, and anyone interested in the ocean, seas, and coast that doesn't have a professional background in this field. So it's a tool that has been developed by the European Commission and that is operated by the EMODNet Secretariat. And I work for the EMODNet Secretariat. This is why I will make the presentation. So it's an online catalog of more than 270 interactive map layers that, of course, you can combine with each other. And very importantly, it also shows to the people who are looking at the atlas where the data comes from. So for each map layer, it is possible to read a description of the map layer in a language that is understandable by everyone. And it has a link and information on the data provider. So we think that it's very important also for the general public and especially in education as well to also always track back to where the information comes from. So as you see, we have map layers on a wide diversity of topics going from nature to sea life and different sectors of the blue economy. And in terms of the blue economy, we have information, for example, such on fish catch or macro and micro algae production facilities, but we also have employment data. So it's really data of different nature. Very important in terms of education, it's available in 24 official languages of the European Union. And it's available to everyone, but also everyone can integrate these map layers and these maps in their work. So for example, we have an export tool that will allow you to export the maps, but you could also embed them on a website and on a blog. And the European Commission would be very happy to see you use the atlas. So the more you use it, actually, the happier we are. We just ask that you mention that the maps come from the European Atlas of the Seas, and if possible, to also mention the website to the atlas so that other people can use it as well. It's totally open access, so it's very easy to access it and to use it. You just need to go to the internet, open a browser and type www.european European Atlas of the Seas, and you will directly have access to the atlas. So you do not have to use any password or carry out any procedure. You directly have access to the atlas. The first thing that you want to do is click on the menu, which is the icon in the top left-hand corner with the 3 lines, and that will open a menu window. There you see on the top row that you have English. If you click on English, you will see a drop-down list with all of the languages so that you can easily change the language. Also in the same row, you have guide feedback, and this is access to an online form where you can ask any question you may have about the map layers, but also if something doesn't work and you have a question on how to make it work, or if you have a comment that you would like to share with us. And I'm on the other side of that form, so happy to answer any question you may have about the Atlas. So once you have set the language, you can close this window and you can start searching for map layers. So to do this, you need to click on the magnifying glass that will open a new window that will be the search window. There are different things that you can look at, but today we will focus on the list of layers. And this is where you can see the list of the 270 map layers. And you see that by each map layer, you have an information icon. If you click on that, you will see the description of the map layer and the data provider. So that will give you an indication on what you can find in the map layer. You also see some other symbols, a little graduation hat. That means there is an activity in the teacher's corner of the atlas linked to that map layer. And I will come back to this later. You also have a little book. That means we have a map story associated with this map layer, and the map stories are accessible next to the layers. And here you have little text that provides additional information on the map layer. You may, in some cases, also have a symbol that indicates that this is a new map layer that has just been added to the atlas, or that it has been recently updated. Because the atlas is a very dynamic tool, so every time you come to it, you may see some changes because there is a new map layer, or a map layer has been added, or we have also added tools so that it is easier to use and you can do more with the atlas. So how do you select map layer, or how do you create a map with several map layers? You just need to tick the boxes of the map layers that you're interested in. So in this example, we've selected 2 map layers, macroalgae and microalgae production sites. Once we have ticked the box, we can close this window and we will see the map appear on our screen. Under layers, we will see we have the 2 map layers that we have selected. And as I explained, if we click on the information icon, we have the description of the map layer, and we have an icon with the data provider. So in this case, for example, we see that the data comes from Embonet. About half of the map layers in the atlas are developed based on data coming from Embonet. Other data providers include Copernicus Marine Service, the Joint Research Center, the European Environmental Agency, Eurostat. So there are a number of different data providers. Of course, it's very important to look at the legend. So we also make the legend very accessible. And you can also click on the symbols in the map to get more information on the different symbols. So when you click, you are able to read additional information, for example, on the aquaculture production facilities. This means it's very interactive, and you can also, of course, zoom in and zoom out to see a specific region or to come back to the European scale. In addition to this possibility to explore the catalog and combine different existing map layers, we have recently also developed the possibility for users to create their own maps. So this is an area of the Atlas that is behind an EU login. So there you have to include a password because it will create your own working space in the Atlas. That means that the map layers that you will be creating yourself will only be accessible by you. But you will be able to share the link to your map layers with your colleagues, for example. So how does that work and how do you access that? If we go back to the menu, which is the icon with the 3 lines, you see that we have a section called Advanced Feature. If you click on Advanced Feature, you will be able to select 3 features. Save Map, that means you're going to be able to save map in your own working space. My Locations and My Notes. So these tools will allow you to create your own map by selecting some specific location and adding information and data about these locations. You will be able to combine the map layers you have created yourself with existing map layers and to save them in your working space. That means that you will be able to come back to your saved map at a later time to update them or to share them with your colleagues or other people by just sharing the URL to the map layer. So this is a simple exercise that we have done using these tools. So for example, if we want to show the temperature measured at different monitoring stations in Europe, we just need to click on the little pin, which is the My Location tool. And there you will have a window that opens where you can create your table with your data. So you can either already have the geographical coordinates, the latitude and longitude, and write them in the table, or you can just click on the location that you wish to show in the map, and it will automatically give you the latitude and the longitude. And in the third column, you can give a description of that location. You can add different columns with different variables. And of course, you can add different rows with additional monitoring stations. Once you have done that, you can click on Next and start developing the different features of your map layer. Just a point to say that you could also, if you have, for example, your data in an Excel sheet, copy the data from the Excel sheet into this table by clicking on Copy from a table. In this case, of course, you at least have to have latitude, longitude, and description. Just a point also to say that in addition to these tools, we also have a teacher's corner in the European Atlas of the Seas with ready-to-use map-based activities. So this is primarily aimed at teachers so that they can organize activities for ocean literacy in the classroom. The Teacher's Corner is accessible from the menu by just clicking on Teacher's Corner, and it includes a map-based exercise with four different age categories, but also some interactive quizzes, some games. So for example, we have a geocaching game, we have a treasure hunt or hide and seek game. We have some posters also that can be used in the classrooms, and we publish on the Teacher's Corner all of the presentations that we have done at past events and workshops. So this presentation too will be published on the Teacher's Corner. So while it's aimed mainly at teachers and students, we think especially for the games, everyone can really enjoy it. And so we invite you to play the latest hide and seek game, which is focused on marine biodiversity. Also important is the fact that we have a map of the week that we publish every Friday on the website of the Maritime Forum, which is a European Commission website. And these maps are the week consist in one of the map layers or a selection of these map layers that we have brought together into a map. that will address a specific topic that is especially relevant that week. For example, because there is a specific conference on a specific topic, or because there's new European legislation, or because there is something happening at international level that readers may be interested in. So our objective is not only to highlight some of these map layers that are available in the Atlas, but also to provide some educational resources to teachers so that they can be kept aware of what is happening in the world of ocean, and also give them some additional resources that they can use. Finally, as Dina explained, we have a lot of synergies that have been built between the EU Ocean Coalition for Ocean Literacy and the European Atlas of the Seas. And the most evident one is a map, an EU Ocean map that is created with 3 map layers, which show the members of the EU Ocean platform, the projects of the young ocean advocates within the Youth Ocean Forum, and the schools that are member of the network of European Blue Schools. And if you go into this map, you are able to click on all of the pieces of the puzzles, and you will learn who they are and what they do. So this is very interesting, not only to show the diversity of activities that are being implemented on ocean literacy, but it also helps members find partners. So it helps the school, for example, identify experts that are working nearby, or young people they could connect with. Finally, a point that I wanted to mention very recently also, the Atlas is now also available on your mobile phone. So up to September this year, we always advised users to access the Atlas on a computer for full access. But now, in the past months, it has been available on your mobile phone. You still, of course, need an internet connection to access the map, but that means that you can really almost have the ocean in your pocket and be available to access this information wherever you are. Just a note on this is that you can explore the catalog, you can contact us, but you cannot create your own maps with the mobile version. So to create your own map, you still need to use the computer.
Thank you very much.
In short, this is what we wanted to say. Here you have a QR code where you can watch our Atlas workshop video. That is a longer presentation where you have more details on how you can create your maps and use this My Location and My Notes tool, and also a QR code where you can access the website where you can read the maps of the week. And while I let you scan this QR code, I also wanted to mention that, of course, if you're not yet a member of the Youth Ocean Coalition and are interested, I think Dina has put the link to the EU Ocean Coalition already in the chat. You're most welcome to have a look and to join one of the 3 communities, and in your case, of course, the Youth Ocean Forum. And if you do, you will be on the map that I have just showed you. So we update this map with in time as we see the coalition grow. So thank you very much. And if you have any questions, don't hesitate.
Thank you. Fantastic, Natalie. I think I will be trying some hide and seek this weekend from the Teacher's Corner. And yeah, I also like the ocean in your pocket idea. So ocean can be on the pocket, in the pocket, can be on a map, can be on a cargo ship, but it can also be in an infographic or any kind of interesting visual asset where we can translate the ocean to somebody who doesn't yet know it. And with that, I would like to invite Miguel Lil, who is leading a very interesting organization called Science Crunches, where they try to unlock science for everybody who needs it, and translate the complexity of science into appealing visuals and games. Miguel, the floor is yours and you can start sharing your screen.
Thank you, Dina. And thank you everyone for being here, and thank you for the organizing committee for inviting me to have this presentation on infographics. So, infographics is not something very easy to do, but they are very important for us to easily understand the science or the data behind. So as Dina said, I'm Miguel Ayala. I'm the founder of Science Crunchers, and a lot of what we do is try to communicate science. And as scientist myself, we all relate with science being, complex. Sometimes, or very often, it's not illustrated, in the typical publishing system that we have in the academic careers. This is a typical format. It's often very long, long deliverables, long report that lack emotions. And for us as scientists, it's okay. We are used to this, but when we want to communicate to the other audiences, this is usually a bottleneck that we face. And indeed, in science, we have a part of doing, which is very objective, and this is how we are trained to think as scientists, but we also have the communication part, which is very subjective. And when we are communicating, we have the content or the substance, which is something objective. We know what we want to communicate and what should be in the message, but the style, again, is subjective. And again, as scientists, style and emotions can be something difficult for us to communicate. So the way that we communicate, including our data and converting them into visuals, also needs some emotion and some style. And what I mean with style is not necessarily just good design, but it's many more things that I'll explain in the next few minutes. So the first thing that we all need to understand is we need to know who the audience is of our visuals. It can be a very scientific expert we communicate with bar plots or box plots or sharp dots or all these kinds of fancy scientific names. Our audience is familiar with them, but if we are communicating to other audiences, then this is not perceivable or it's not easy to understand. So if we are communicating for the industry, for instance, something that conveys some technical data and some information combined with some strong and sharp key messages and nice design, it's more appealing, but also informative for those who are technical aware of what we are communicating, but not don't have the patience or don't in the background of all the scientific data behind the communication that we're doing. And if we're talking to the general public, then it's a whole new story, because not only we need to tell a story, but we need to catch their attention. This is an illustration we've made in the past to communicate that fishing nets can be made of hair. And ideally, the goal is that only with this simple illustration, people want to know more and want to listen to our story, so they are engaged. So to know your audience is basically improving this connection between the communicator and the receiver of the communication, the effectiveness that the communication is made, and again, the receptiveness, so the willingness to hear what we are saying or trying to communicate. But the question is, how do we go from graphs to an engaging story? And that's where infographics come in. And a good definition of infographics, this one in the screen by Brian Wallace, that says that infographic is not a chart or a collection of graphs. It tells a story in a visual manner that makes difficult topics easier to digest for readers. So it's not what we see, when we publish in scientific journals and they ask for a graphical abstract, and we all put together a collection of plots from our article, and that's, it's the best that we can do probably, but it's not really an infographic. It's not telling a story. It's just a collection of graphs. And I like to highlight these two examples of really good infographics. And the one on the left, for those who don't know, it's the story of John Snow and how he identified the sources of cholera in London in around the 1850s, where there was a huge cholera outbreak and the authorities were not able to control this. And John Snow was a a physician, I think, and he used the map to pinpoint where all fatalities were taking place. But he also had a theory that color was being transmitted by water sources. And so by mapping the locations of the fatalities with the locations of the water sources, he was able to provide some guidance on how to restrain and control cholera. And this is a very clear way to show how a visual allowed new perspectives to be seen on a problem that needed a solution. And the other example is, the map, in this case of the London Tube map, but many cities already have this kind of maps, where it's a map, but we don't actually care about geographical references, because what we need is to understand how to go from point A to point B, and what we need here is utility over accuracy. So again, the important part is to understand who is our audience and why are we communicating what we are communicating. And based on that, instead of trying to make a very complex map of the city of London and all the tube stops, we designed this kind of maps that became very easy to grasp and to understand for tourists that visit the city. So, but what makes a good infographic? And here comes the complexity, because you need data, because if you don't have data, you don't have content, right? It's important to have a good design, the topic, the colors, the fonts, the contrasts. It must be readable. And it should also tell a story. It should have a clear message, a clear solution to the problem that you are describing. But it should also be shareable, or be viral, if we're talking about social media terms. Because if we have, a great data set, a great design, and a great story, but in a format that we cannot share it, it's basically losing all its potential. But if we have, for instance, a very good design, a very good story, and it's very easy to share, but the data is lacking, or it's not substantiating or supporting our message, basically, it can be a bit embarrassing or even damaging to our reputation, because we're telling a story without any substance. So this sort of four dimension Venn diagram tries to explain what are the consequences of not thinking it through, not considering these four different axes. And so we have data that is supporting the message that we're trying to communicate, but we need a story to be the key driver. One without the other makes it very difficult for the receiver of the communication of the infographic to be engaged or to care about what you're saying. So in our agency, we follow these 5 fundamental steps to build an infographic. We need to understand what is the goal of what we are communicating. Based on that, we need to build a message, identify the target audience, then do what we call crunch the topic, or summarizing, or synthesizing, organizing the information. And only the last step is to design the story. So myself as a scientist, I work on the first 4 topics, which are very important, and they need the support of the design team to make it nicely illustrated. But a nicely illustrated story without all the other 4 steps considered, it's not going to be a successful infographic. So this is how we try to turn stories into visual concepts. And to analyze a few examples, I'm not going to give you the time that you need to go through this infographic that shows the evolution of sea lice treatments in salmon. So sea lice is this parasite copepod that kills salmon, and it's very bad for the aquaculture industry. And here the goal is to communicate the trends of different treatments that have been used to control sea lice since 1992. And we need to understand what is the strategy behind. So the goal of the infographic is to lay the grounds for a new product, for a new solution that is going to, to be important for the salmon industry. The target is the industry. The what is to understand what kind of treatments we have been using. This was going to be used for commercial pitches to introduce the need for a new product in slide decks, in commercial visits to potential clients, and also to use in the website. The way that this infographic is structured, it has a story. So it has a setup. For those who don't know, the storytelling has these 3 different steps: the setup, the conflict or the problem, and then the resolution. And here the setup is to introduce that sea lice, has been a problem. It has a big conflict because we have been changing treatments and using more and more treatments in different quantities all over time. And you can see visually that by the last few years, we are using a lot of everything to try to constrain this issue. And basically, this is what we have used to introduce the solution, a new product, a new solution to control sea lice. Something important also when building an infographic is the visual structure. In this case, we call it the timeline. It's clear because we are showing a timeline, something through time, but sometimes it can be a control versus treatment. So, a mirror or something with a 1-axis or 2-axis structure. So depending on the story and the data that you have, you need to have a structure, a backbone to your infographic. Other examples, this one I've showed before, we want to show this cascade effect and the timeline effect of a carbon reduction pathway for this industry. So we are showing here how the different drivers of the carbon footprint can contribute to reduce the footprint and ultimately have a pathway to achieve the sustainability goals of this company. Another example here, and apologize, it's in Portuguese. It's about the different species that we have in Portugal in the forest area. So not only it has some illustration elements, it has a lot of data behind, but you can see the combination of trees or species, economic indicators, and the story. You have a title, you have a context, and we guide you through the information that you want to read. So my last 2 slides are just 2 examples of other infographics we've worked on, and I just want to go through the different steps of developing it. So the goal here was to show what are the cumulative pressures in the marine environment. This was done within the scope of an Horizon Europe project, the Gas for Seas. So the format was made squared because we wanted to communicate in social media. So social media was the main channel. The story was to show how the different pressures can be cumulative. So you have this color effect in the ocean that clearly depicts that a light blue plus a light blue turns into a darker blue. You have this structure, and the design in the end was basically showing this cumulative effect. And I was very proud to, I think, call this a viral infographic. I think in a month he got more than 15,000 views without paid advertisement, and it was really nice to see a lot of good feedback. This is an example of a huge data set that we have received from the CBE, so the Circular Bio-Based Europe Joint Undertaking from the European Commission, where they had for each country different indicators on how many projects were funded, if they were funding SMEs or other kinds of institutions, how many beneficiaries or how many different institutions were coordinating the projects, etc. So basically, we created an infographic per country to summarize in a very visual way all types of data that they wanted to communicate. So the format was to fit a slide deck or also social media. The story I already told you in terms of having a country-based data structured on the main elements that they wanted to highlight. So the locations of the projects, the type of institutions and the funding, and only then we worked on the design. So I hope that in these few minutes you understood that to prepare infographics is not just to have a skilled design team, but it's to think about all the steps before doing the nice illustrations. And I hope this was useful for you. So thank you very much.
Thanks a lot, Miguel. Really inspiring, I think. We're getting great feedback already on the chat. So let's see further into the ocean and creativity connection. something that we've heard already from several speakers, and Miguel has brilliantly demonstrated how to step outside of the scientific thinking and, while being a rigorous scientist, create something appealing. And now we will go further with Kiat Ng from the University of Lisbon's Center for Ecology, Evolution and Environmental Changes, how to connect the ocean science with the creativity that we all share as humans, and how to together try to move to a more sustainable and more respectful relationship with the ocean environment that we all want to achieve in the sustainability agenda. Kiat, the floor is yours.
Sorry, thank you, Dina. And thank you, Ana Victoria, Dina, and the whole team for this amazing session. It's been really insightful. And thank you all the previous speakers for the insights, and also everyone else for your presence. As we've heard, and also thank you, Miguel, for paving the road of this presentation. I am living kind of in the liminal zone between being a researcher and communication. So definitely Miguel is someone that I work with. I'm not doing what Miguel has already presented to you. So as we've heard from also the other previous speakers, data carries responsibility, and also data is the rock where science sits on. And from my perspective, I see us not as data owners, but as data caretakers. So how can we tend to the data that are in our responsibility? And how do we steward this further processing and sharing of this data going forward, irregardless of which stage of the research process you are in? Some of us do not have the luxury of being right in the beginning of a research project, like some of you have already reflected. And that sometimes looks like a mission impossible, but I would say do not give up. And I hope my presentation today could give you some glimpses of different imaginations. I would first like to ground my presentation in 3 big questions that guide my own work and experiences. The first question being, why are we doing this? How can the selected sets of data support the well-being of humans and more than humans? And by saying more than humans, I mean animals, plants, beings, mushrooms, insects. And when you start to think about the why, and it also, again, doesn't determine, it's not important which stage of the research process you are in, because you can actually make a decision to adjust and work with a data based on the presentation style or the selection process. And then the next question is then, after having your data ready, validated, ready to share with the world, then who would you actually like to communicate and share your data? And not only like to, I would say also wish to or need to in many cases, because a lot of our results as researchers stay within the academic realm and never really reach out and engage the general public. Then if you have identified the who, as Miguel has identified, then the how do you turn the data into accessible, digestible, user-friendly, and also relatable form and style for the intended end user. This process of translating into meaningful, accessible data for the end user is a long process. It's reflective, it's collaborative, and it's also a co-creative process that includes many different disciplines. I would share with you a few examples to share my own experience in the process of translating data into meaning through different research projects that I have been involved in with different disciplines and approaches in different contexts and across land and ocean. First example that I would like to share translates climate adaptation data into comparative visual insight. This is a EU FP7-based project called Bottom-Up Adaptation, Climate Change Adaptation for a Sustainable Europe. And towards the end of this 4-year process, we have 23 in-depth, long, living documents of climate change adaptation case study research across Europe. And we have identified that we would like this message to reach decision makers, practitioners, and citizens. Now, how can we do this? This is one of the cases where this part of the project on how to communicate was not fully thought through, as in how to then communicate these very lengthy documents in a digestible and also appealing manner. And so what we did was, through a collaborative, iterative, because it's many rounds, and also have to work with graphics designer or people like Miguel, and also with the content owners, which is 23 different content owners, on a comparative, because it has to be comparable, all the 23 case studies. So we did come up with a meta-analysis of all these 23 case studies, and still we have published paper, but that's still not enough. So since we have some budget left and we have time and my big enthusiasm, we translated these long documents into cases that is based on a magazine style format. And from the concept to the icons to the color, as Miguel has also indicated, everything was carefully thought through and discussed through multiple iterations with the graphics designer, and also the content with the case study owners. And then we came up with the adaptation stages being like the core concept that could probably be useful to help readers navigate the different sections of the books. And also the different sectors, is it agricultural, is it coastal, is it water resources, will also help direct readers to the right place. And also someone, example, experiencing, let's say they are stage 1 adaptation, and they would probably be most interested in the stage 2 or stage 3, because stage 5 and 6 would be a bit too out of their range for the time being. So this was the thinking behind the process. And what came up on is a book of adaptation insights across Europe, showcasing all the 23 cases with, I think, graphically appealing concepts. And then the next example that I would like to share with you distills coastal science for data-limited regions. In this research, I was in the luxury research ideal scenario where I was right in the beginning to seed the concept, the idea, the design from the onset with a group of multidisciplinary team. And our research question was, how can we translate complex coastal science into simple yet holistic tool for planners and decision makers in data-limited regions? Because you can use models, you can use a lot of data that you can get from all over the places for places that have data. But in places that don't have data, you really need to think it through, like, what are the key indicators and parameters that will be relevant for a region-wide scale project. And we so included, to create this meaningful data, we included local knowledge, coastal engineering knowledge, GIS, field survey, socio-ecological resilience, coastal planning, and also geomorphology and geology. And the outcome of this project was a broad-scale integrated coastal vulnerability indices. There is no time to go into detail, but it really shows you the phases of a process of how we then come up with these vulnerability maps for all 9 islands that are comparable with common parameters that could be a useful tool for decision makers. And with that, I come to the last example of the day. And this is part of Embracer project, which is nature-based solutions for the Atlantic region. This is a workshop held under that project. It's a multi-acted workshop for Cavado region in the northern part of Portugal. And in this workshop, we had a walk along the river where stakeholders who have not met before in person, only through emails, get to actually talk to each other informally and connect, bonding through a long lunch that then lead into a personal storytelling session where they get to share their own stories and also values of their region, of their place. So it's a place-based approach and also an emotional approach, not only writing about facts about climate change or risks, but really how they experience. The river has changed since in the early 40s, where this used to be a dumping ground, and now it is slowly becoming a sacred ground whereby nature-based solutions is integrated and human beings are reconnecting with the river. Now, how can we translate these stories and values that we have gathered from this workshop? We were very lucky to have a landscape architect working with us in our project. And so we co-created a visual semi-live sketch because he wasn't able to be on in person, but online, and came up with a metaphorical map, kind of as Miguel has also pointed out. This is, in the beginning, our first approach being very technical based project. We were opting for a very detailed base map, like the real exact map. But we felt that that wouldn't really connect with normal people, as normal as in citizens. We would like to highlight certain aspects, like from the connecting the mountain, from the river to the sea, creating this identity and I think pride of the people from the area. So this visual will also be translated into local language, Portuguese in this case, and it will be serving as a starting point where we turn data into a space for dialogue in future events. And with that, I've come to the end of my presentation. I'm sharing with you here one of the exhibition pieces from Voices of the Youth that we have launched. And it's a beautiful artwork and storytelling exhibition of this girl from Bangladesh, among other pieces. And I do not have conclusions or messages really to share, except a gentle invitation for you to pause, reflect, imagine, and create what translating data into meaning is for you. Thank you.
Thank you very much, Kat. Very inspirational. And we will pause right now for a Mentimeter session all together, and I will invite Anna Vittoria to run this session for us. We can share our views on what it is to communicate about the ocean, how to communicate based on data, and what it is to be ocean literate and transfer this to others. Anna Vittoria, this is now for you.
Thank you so much, Dina. So I'm sharing also with you, prior to the Mentimeter, the code for you to join us. You can join by the code, which is on the chat. Just 1 second. You can join us by this code on the chat. I will give you some seconds so you can enter directly there. Or you can just type on your browser the code that is right in the top of this page. So yes, we would like to know from you, because today you heard this translation from data to diverse target groups. And we would like to hear from you. Who are the users of marine science, in your opinion? Who later benefit from marine science? Who also use marine science? And I see you are also bringing policymakers as a big word. Everyone, because yes, indeed, everyone benefits from the ocean. We all depend on the ocean. Citizens, scientists, industry, researchers, general public, ocean cleanup, civil society, coastal communities. So yes, we have many different users, right? It's not just a single user. We have different types of users of marine science, and also this the presentation of Miguel, for example, was very important because we could see how data can be translated to diverse target groups, and how also we can use from tools like science communication to bring data into life. And I see you are still bringing more users, but I will pass to our next question, which is how to make marine knowledge more accessible. So what do you think would be a way to make marine knowledge more accessible to everyone? How we could make ocean knowledge more accessible with open collaborations, visualize it in simple ways, uniformity, make it more present in everyday life, remove paywalls, simple visuals, creating stories. We saw the power of that today, right? With Kiat presentation, also with Miguel, as well with the Atlas of the Sea. So we see that also connecting people to stories on how this data was collected, for what purpose this data serves, also can connect a society in a more meaningful way to science, giving open access, scientific mediation, art. We saw as well from Kiat the importance of reflection, right, on this process of science as well. Popular science, stepping away from seeing ocean literacy as talking to kids in school. It is a very important part of the work on ocean literacy, but we also need to talk with other targets, right? So bringing the ocean to schools, it's important, but we also need to bring it to more targets. News, interesting. So bringing maybe the ocean to the news, to the journals, right? Collaboration, simple language, make it mainstream, open, fair data storytelling, ocean literacy again, make scientists more valued. That's a very important aspect as well. Connecting with social media. So we saw today that there are many tools to make our science more available, and making it more visually interesting as well. It's one way to get the interest from the public. Scientific dissemination and communication. Thank you so much for those audio and visuals. Simplicity. So you saw, right, we have this scientific process which is highly complex, but when we bring it also to other targets, we need to simplify the message, but not make it dumb, but make it more accessible to other targets, right? I will make it fun. Yes, that's another aspect we need to keep in mind always, because we need to sparkle the interest of people, right? And now I would like to know from you, have you ever heard about ocean literacy before, or if this is a new topic for you? I see that some of you already are familiar with ocean literacy, which is quite good. And for some of you, this is a new topic. So you saw that this training is also connected to this aspect of ocean literacy, right? Because we have data, but we also need to make this data more accessible, more available to society as a whole. So everyone can understand why the ocean is important, but also why it's our life support system at the end. And for that, we need tools. And ocean literacy is one of them. So I see that many of you are already familiar with ocean literacy, which is great. And I will pass to our next question. What is ocean literacy? So you can choose here the best description. We have knowing marine species names, being able to swim in the ocean, understanding the ocean influence on us and our influence in the ocean, or studying oceanography. I see that probably that's a very easy for you. Ocean literacy is the understanding of our influence on the ocean and the ocean influence on us. So also being able to translate the ocean meaningfully to diverse target groups makes you a more ocean literate person. And our aim is also to bring ocean literacy to a big number of people, as well to the scientific community. So thank you so much for replying to this question. And what ocean literacy approaches do you use in your work, or do you want to use in your work? So we would like here to know from you what type of ocean literacy activities you are already doing in your institution, or that you would like to do. Co-designing in my thesis, talking, even to strangers on the bus. Yes, I think that's also a very good point, because when we talk about our research and what we do, which sometimes is something so complex, we make the message more decodified, right, to diverse people. So I always keep something in my mind, because if I'm able to explain the ocean to my grandma, I think it's a good path, you know, for making the message more accessible to everyone. Infographics already used, storytelling would love to master, surveys, interactive sessions for my thesis again. So it's very good to see that some people are bringing more than one time the will to use ocean literacy in your thesis, right? Because we also don't want those projects to stay in the university shelves, but we want them to come also and be part of the world. And so using ocean literacy on the thesis process, it's also a very interesting process. Co-designing, we saw that from Kiet as well, the importance of co-designing. Education through videos, education conservation workshops, so talking with communities, with locals, with citizen science. We saw today as well the talk from Charlotte, right? The importance of citizen science through public presentations, simple sessions with communities, targeting knowledge dissemination, education, sharing it on social media. That's again another aspect that probably all of us can do, right? On sharing a bit of ocean concepts on social media, creating ocean infographics, effective action oriented. We saw as well from Miguel the process that he has in Science Crunchers for creating an effective message with an infographic, and I think that's very usable and important for all of us. Through art, I try to communicate my scientific studies interactively with the local people who are indigenous to the environment in which my studies have taken place. So community awareness as well is one topic and one need. Science communication through surveys. Thank you so much. I've used myself to collect data. I think many good answers so far.
Thank you so much. Yeah, great. I think we will have to stop here with the Mentimeter. We will keep some questions for tomorrow, because we want to keep the creative juices and your ideas flowing. And I would like to pass now to Juana Jimenez, our co-organizer from the Flanders Marine Institute, to give Juana your reflections of today. I think it was very inspiring, very rich, and good luck to you to try to summarize it in a few minutes. And then after Juana will remind you about the program of tomorrow, and we will see each other tomorrow for another exciting day. Juana, now the floor is with you.
Thank you, Dina. And indeed, it's becoming a difficult task having so many presentations, but especially so much insights and comments and interesting questions that we're having on the chat. So we started with citizen science, which allowed giving us this how the data can flow from the collection, but especially giving a great emphasis on, for example, how local experts are so needed from all the data for all the data to flow fluently and leads to a right direction, because we need them to this translation of how the data is collected, especially when we are talking about citizen science projects. And something that especially catch the attention of all of us is that
is not only she presented some steps on how we can indeed start with control vocabularies, have some standards, read if they are there, but this won't stop you. You can also keep your data as clear as possible and share it with the network. So this could also open the benefit for all of us, that you don't have to wait that this is created, but you can start creating it by yourself as well. And something that I saw, and it connects with our later presentations, is the different licenses and the different pictures. And I think for all of us, we will need a really good translation and infographic of what all the licenses are actually meaning, so we can make use of this. And her last comment especially leads me as well to the next presentation by Lancelot from ILBO, which is that FAIR is an spectrum. So it's not only black and white if we are applying it or not. And Lancelot gave us a good example that's how this starts from indeed a challenge, but it turns into a solution in terms of how we can be open and how we can share this as a best practice of a win-win situation involving from the beginning a critical stakeholder, which is the fishermen. So I would like to again reminder also the other presentations that we have. For example, in the Blue Cloud 2026 by Ciriel, we have these amazing virtual laboratories that it goes from aquaculture to plankton genomics. And again, another reminder that there is a lot of sources and webinars and that you can find on the website. So I invite you again to reach out to the website of Blue Cloud and have a look at it. And then the great example of Andrew, and we were commenting with Alice here, who is also part of the organization team, that such a perfect spot, like actually we were saying that people cannot escape from the boats and the cruises. So they're actually more engaging. Maybe they will take more time, and this also allows you to know and get extra data and feedback for an audience that will see it from another different perspective. So you are gaining actually more insights, giving it this information and this visibility to your data. And talking about visibility of the data, we went to the European Atlas of the Sea. And as well, I think Natalie said that is the 24 official languages of the EU, but I think I will emphasize more on how this is also an inclusive tool, that you are not stuck sometimes what happens with science, that everything is in English, but here you are able to connect and that many people can use it. So also it was amazing to see that now you can have it on your mobile phone, which is make it very accessible, not only like for many people, but also when we are talking about this collection and data. So when you're on the field, you are able to access this amazing tool, which again, I invite you to have a look at it. And going, okay, now how are the tools and how we can translate them and bringing out, as we were saying from day 2, outside our bubble, how we can reach more people. And Miguel gave us a good starting point. Like, you have to know your audience. You have to ask like which key messages you can share, because sometimes you only have 1 minute or maximum 5 minutes, and you have to be as clear as possible. And this is not only to engage the general public, but I've seen it also myself that this is a good tool how you can get access to funding. So how you can share like what your services or what your research study, or when you have to explain your PhD, for example, you have a few minutes, a concrete message, and like how this can support you. And Kiet as well, it was a great presentation on how we can translate the data into a not only like for scientists, but having this connection, emotional connection approach, which also leads to giving it not only ownership to all the persons who are involved and participating in the project, but having them involved and creating this ownership, strength the collaboration, and strength how the message can be shared. So with that, I would like to finish our conclusions, our ideas, and as a last thought that I forgot actually to include with the presentation of Andrew is also to put it on the table if we will see these screens and this projection in the next EuroGoose conference, which now I will also get you the kind reminder that you can submit your abstract as well. So don't miss that opportunity. There are very excellent topics where you can jump in on it. Thank you, Dina.
Thank you very much, Juana. Excellent wrap up. Thank you, Alice, for helping so much with the program. I think we have managed altogether to secure fantastic speakers and also great audience. So let me share the slide for tomorrow's day, so you know what new surprises we have reserved for you. Let me see if I'm able to share correctly. I think like this, most likely. Yep. So we will hear more about the impact of data from a global initiative on ocean data sharing as part of the UN Ocean Decade. We will also hear about more about the clearing house mechanism of the BBNJ treaty, which is a very, very important development in terms of conservation and how marine knowledge can inform decisions at the global level. We will dive to the bottom of the sea with Seabed 2030 initiative, which is another global development, and also into the Global Fishing Watch, where we'll hear more about using fisheries data towards sustainability. So an interesting day tomorrow. We will have other Mentimeter interactions all together. So you can pose your questions, you can reflect, you can share your ideas. And we hope to see you all tomorrow. And here's our final slide. And thanks again to all of you. See you tomorrow.
Thank you very much. Good evening.
Bye-bye. See you tomorrow.